science and art lecturers in St Mary's University College have long recognised opportunities for connected learning in the primary curriculum. We devised an experimental and innovative teaching programme for children aged 7 to 10 on the topic of flight and tested it in 4 primary schools.
You might want to make a few wee quick sketches around the side of your page as to maybe the shape of his feathers. Maybe just a little 10-second sketch from what you can remember.
We exploit what is common to teaching and learning in art and science. This enables the synchronized integration of the subjects within lessons.
Now look at the size of the wings compared to the body. Normally when you see a bird, its wings are all folded up, so they don't look so big. So whenever you're drawing it, make sure you get it to the right scale.
As a result of investigative, explorative, experimental and creative activities, children apply their knowledge of flight in the design and making of imaginary flying creatures. The project facilitates the use of joint learning outcomes for art and science.
Okay, yeah, very good. Okay, and can you see any patterns or lines?
I see lines. I see lots of lines.
This pushes the boundaries of subject interconnection, provides a vehicle for creativity, the acquisition of skills, and having fun while learning.
Look at that one.
We follow 4 classes as they investigate, experiment, develop ideas, imagine and create.
Teachers introduced the topic of flight to their classes and listened carefully to their thoughts and ideas.
It was only after I explained to the pupils that we were trying to get as many ideas as possible that I realised what was happening here. The development of creativity, language development and social and emotional development.
None of the teachers drew up a preconceived scheme of work. Planning was much more subtle, allowing for flexibility, development and ownership by the children. There were 4 stages to the programme. Stage 1, observation and gathering of information.
Don't drop it on the ground. Go over and lay it down.
All 4 classes visited a local wildfowl and wetlands trust centre. Teachers reported that this was highly motivating, providing immense scope for sensory experiences.
Giving the children first-hand experiences enhanced their learning. They have retained what they have learned.
Yep, and her eggs hatch into baby ducklings, yeah.
Children observed and recorded images in sketchbooks and using digital photography. They listened carefully and made drawings of the sounds they heard.
Okay, you ready? This is what I'm doing. I haven't gone mad, okay? This is called my sound chart, everybody. And this is what it is. This is what I'm hearing. This is exactly what I'm hearing. And I'm not writing it down in words. I'm writing it down in a code. So, I have 2 stars up here. So this is my quack, quack, quack that I heard. This is because I can hear the wind. And I was being really quiet to listen for it. So I put this down for the wind. I also heard a woo. And I also heard someone say, I wonder what she's doing. Who was that?
They organised their own collections of information while the teachers acted as facilitators. The children created clay models and pastel studies of birds. Birds that they could explain in terms of their physical features and respective function. This represents an example of the natural symbiosis of the 2 disciplines, while involving children in an engaging learning activity which is personally satisfying.
Okay, so what are you doing, birds?
Stage 2. Developing ideas. This stage was essentially practical and investigative, involving first-hand sensory experiences. Exploring, observing, recording, listening and discussing, experimenting.
As we sketch the feather, and then we're going to print.
Bombardier Aerospace provided a suitably real starting point for exploration of the forces related to flight. This created a bridge between education and industry. Accessibility to the topic was increased through the use of visual, oral and kinesthetic experiences. Camouflage was investigated through creative camouflage experiments involving colour, pattern and light. Experimentation with materials was open-ended, allowing for creative and imaginative thinking.
Stage 3. Creating imaginary flying creatures.
We're just going to begin by reminding ourselves what we've talked about in making our creature so far, the different features that it's going to have and the way that we want it to look when it's finished. Now, okay, so we talked about the head and it's going to be shaped like an airplane. Anybody remind us of what kind of eyes we want our creature to have?
Owl eyes.
Shh, without shouting out, put your hand up, Colin.
Owl's eyes.
Owl's eyes. Why did we think it was important that it should have owl's eyes? Where did we see owl's eyes? And how do we know about owl's eyes?
Because you can see from away.
Children invented and constructed imaginary flying creatures by applying their knowledge and experience.
I got 8 cartons and I got green tissue paper and I have the pink glue in the middle of the tissue paper and put it at the front and wrap the tissue paper around and put elastic band on to make it stick.
This activity was rich in opportunities for extensive problem solving and independent thinking. The children were required to evaluate the design of their invention and justify the reasons for their decisions. Synchronizing art with science resulted in more creative teaching and learning experiences.
Stage 4. Extension, animation. The extension activity allowed for the embedding of experience in children's learning. They created a narrative starring their own imaginary flying creatures and produced an animated film.
Here's the tape of Lucky and her parents. Lucky is a rainbow bird. Wish, wish, clippity clop. Lucky hunts for fish to eat, but sharks